Okay, now let's solve question number 11. So question number 11 says on diagram 1, sketch the graph of y is equals to x times 3 minus x. Okay, so that's one graph that we have to sketch, one diagram. And the other is x times x minus 2 times 5 minus x. Now, one thing to observe before we start is that this is a quadratic curve and this is a cubic curve. How do I know that? Pretty simple. The maximum power here is going to be x squared. The maximum power here is going to be x cubed. Okay, now we dive deeper and we see what exactly the graph is going to look like. So the first thing is that, and in fact, let's read the question further because we do have some guidelines, and it says showing clearly the coordinates of the point where the curves cross the coordinate axes. That means the x and the y-intercepts. Okay, so we have to make sure that we show the x and the y-intercept. So let's start, let's find the x and y-intercepts. Okay, so let's start with y is equals to x times 3 minus x. Now, in order to find out the x-intercept of any line, any curve, we equate y to 0. Okay, so let's equate y to 0 to find out the x-intercept. So when we do that, we have one x-intercept is 0, which means that the curve will pass through the origin. And the other x-intercept will be 3. So you can do it directly or you can do it step by step. 3 minus x equals to 0 is the other equation we need to solve. So that's going to be x equals to 3. So we have the two x-intercepts, 0 and 3. Okay, now next thing that we have to do is we have to find out the y-intercept. Okay, so all this working was for x-intercepts. Now let's find out the y-intercept. Now for y-intercept, we equate x to 0. Okay, so x times 3 minus x, this is the equation of the curve. If I plug in 0 in place of x, so that means 0 times 3 minus 0. So everything just becomes irrelevant because we have to, as soon as we multiply by 0, we will get y as 0 as well. Okay. Now that we have the x and y intercepts, the question is, what is the shape of the curve going to be like? Because we should know from prior knowledge that a quadratic curve could be something like this or it could be something like this. So how do we decide that? Well, if you expand this, if you open up the brackets, you will get 3x times 3x minus x squared. So the fact that the coefficient of x squared is negative, that means we will have a sad face, a maximum curve. Okay, that's what we call it. So let's mark the points and let's start putting it together. So one point, as we saw earlier, is the origin through which the curve will pass. The other point is 3 comma 0. That's the other x-intercept. Okay, let me just label this. Try and be as accurate as possible, even though it's a sketch, but still it's a good idea to be as accurate as possible. Now we don't have to find out the turning point, so don't waste your time trying to find out the turning point. The question hasn't asked us to do that. Okay, so we're just going to make sure that we get the x-intercepts right and we get the shape right, and that's it. We are good to go. So here's the first graph. Okay, a good idea. Let's see if the question has asked. The question hasn't asked us to label, but it's always a good idea to label. Leave no stone unturned, especially when you're solving a paper. So this is going to be y equals to x into 3 minus x. Okay, don't end up taking too much space because we have to sketch the other graph as well. Okay, now the other graph that we have to draw is a cubic graph, as we saw earlier. Now here also we have to do the exact same procedure. We have to find out the x-intercepts, the y-intercept, and we'll determine the nature as well. So let's start by writing down the equation of the curve. It's y is equals to x times x minus 2 times 5 minus x. Now let's start with the x-intercepts. Now for the x-intercepts, as we saw, we're going to equate y to 0. So x times x minus 2 times 5 minus x equals to, sorry about that. Yeah, equals to 0. So that means x equals to 0 or x equals to 2 or x equals to 5. So we have three x-intercepts, 0, 2, and 5. Okay, now let's find out the y-intercept. So how will we find out the y-intercept? For the y-intercept, we will equate y to 0, x to 0, sorry. So y equals to 0 times 0 minus 2, that's minus 2, times 5 minus 0, that's 5. But all of it becomes irrelevant because the y-intercept will come out to be 0 anyway. Okay, just a second. Yeah. So now that we have the x and y-intercepts, what about the nature? So once again, a cubic curve, bear in mind, could be something like this, okay, known as a minimum maximum curve, or it could be something like this, known as a maximum minimum curve. So how do we figure that out? How do we figure out what this curve is going to be? So if you expand, not like expand all the way, but if you just multiply all the x's, so x times x is x squared, x times minus x is minus x cubed. So the fact that it has a negative coefficient of x cubed, that means it's going to be a minimum maximum curve. So this is the kind of curve that we are going to draw. Okay, now let's start by marking all the x-intercepts. So the x-intercept is 0, 0. Then I believe it was 2. So here it is. And then there's 5. Okay, so bear in mind the shape of the curve. Yeah, so do bear in mind the shape of the curve once you have, do keep the shape of the curve at the back of your mind. So we are going to draw a minimum maximum curve. So here are the first two x-intercepts, and then finally the third and the final x-intercept. And that's it, job done. We had to show the coordinate intercepts, we've done that, so we're good to go. Let's move on to the next part of the question. So we're done with part A, we're done with part B, we're done with A part 1, A part 2. Now part B says, show that the x-coordinates of the point of intersection of the two graphs, as you can see they're the same equations, are given by the solutions to this equation. So point of intersection can basically be obtained by solving the two equations simultaneously. So that's exactly what we're going to do. We're going to solve these two equations simultaneously, and the only way that we can do that is actually by equating them. Okay, so since they're both equal to y, we're going to equate them, and then we're going to try and bring them the way the question wants. Okay, so let's expand them while we're at it. So one equation would be y is equals to 3x minus x squared. And the other equation would be, so here be a little careful, don't go all out. I would suggest do it in bits and pieces. So first let's multiply these two brackets. So that would be x squared minus 2x. Let's leave the other bracket intact. Now let's multiply these two brackets. So x squared times 5, that would be 5x squared minus 2x times 5. So that's, or rather, let's multiply x squared with minus x. So that's minus x cubed. Then we have minus 10x, and then we have 2x squared. Now let's write it nicely. By that I mean let's write the cube first. Let's add whatever it is that we can. So we have positive 7x squared and then minus 10x. Now they both can be equated. So let's do that. 3x minus x squared is equals to minus x cubed plus 7x minus 10x. Now keep your eyes on the prize. That's just a fancy way of saying that keep in mind what it is that you're supposed to bring it equal to. Okay, so let's move all the terms to the left hand side so that x cubed can be kept as positive. So x cubed, and then we have minus x squared from before, and then we have, and okay, just realized that this is actually going to be 7x squared. Yeah, so let me just make that correction. So minus x squared minus 7x squared will actually be equal to minus 8x squared. And then 3x plus 10x, that's equal to plus 13x, which is equal to 0. So all we have to do now is to take x common. So we have x squared minus 8x plus 13, close the bracket, equals to 0. And that's it. This is what we were supposed to bring it equal to. And we have done just that. So job done. And you can just write as shown here for good measure. And that's it. Let's move to the next part, which is part C. So let's do part C here. Now part C says the point P lies on both curves given that P lies in the first quadrant. So first quadrant basically means that x and y are both going to be positive. Find using algebra showing you're working the exact coordinates of P. Okay, let me just paste this here so that it's easy. So notice that the question was technically just setting us up for this. Okay, now what do I mean by that? Meaning that the working that we did for the previous part is actually what we're going to use over here. Okay, now in order to find out the point of intersection, okay, P is a point which lies on both curves, so that means that's a point of intersection. We have to solve them simultaneously, and you know what, we've just done that. We have already done that, and I should have used this form, but anyway. So we can see that one point of intersection is x equals to 0, and if you refer to the graph, we can actually see the two curves intersecting. Okay, and there is going to be another point of intersection somewhere over here. This is the first quadrant, and here you can see that x will be positive and y will be positive. So that means once we solve for the next points of intersection, we're going to only consider the ones where x and y are both positive. So this is the equation that we need to solve if we want to find out the other point of intersection. Now we can't solve this by middle term breaking. That means our only option now is to use the quadratic formula, which is mine. No need to actually write down the formula, but I mean, if you want, to be on the safe side, you can for your own sake. So I'm just going to straight away plug in the values, and I will write down the value of a, b, and c. So a is equals to 1, b is equals to -8, and c is equals to 13. So let's plug in these values in the quadratic formula. So minus -8 plus minus square root of b squared minus 4ac. So that means -8 squared minus 4 times 1 times 13 divided by 2a. So 2a means 2 times 1. Okay, now let's simplify. So we have 8 plus minus square root 64 is the square of -8, and 4 times 13 is 52. So 64 minus 52, that's going to be equal to 12. Use your calculator if you're not feeling too confident about your mental maths, nothing to worry about. So here we have the, this is not the simplified version, but if you simplify it using your calculator, you will get, so 4 plus minus under root 3. Okay, now how do you simplify? So basically you will first rewrite the simplified version of 12, which is equal to 2 under root 3. Okay, and then divide by 2. So once you divide everything by 2, you get 4 plus minus under root 3. Okay, now interestingly, both of them are positive. Okay, both these values, 4 plus under root 3 and 4 minus under root 3, are actually positive. Okay, now the question is, how do we know which one is the solution that we want? So what do we do for that? Well, here's what we do. We find out the corresponding y coordinate when x is equal to 4 plus under root 3 and when x is equal to 4 minus under root 3. So let's start with plus. So when x is equals to 4 plus under root 3, sorry, x not y. Let's see what is y equal to. So y, as we saw, was basically equal to x into 3 minus x. Okay, now this is the easier version. This is the easier equation that I'm going to use so that I can easily solve for y. So 4 plus under root 3 and then 3, okay, so better use a square bracket here, minus x, which is 4 plus under root 3. Now let's simplify this and see what we get. So we get 4 plus under root 3, it's nothing we can do about that, so we'll just leave it as it is. Now this would be 4 minus 3, so that's minus 1 minus under root 3. Yeah, so this, there you can see that minus 1 minus under root 3 is going to be a negative value, and this is a positive value. So what happens when you multiply a positive value with a negative value? We get y as negative. So that's not possible. Okay, it doesn't even matter what the final value is. We're just not interested in this value because we want the value where y is positive. So we're just going to ignore that. So that means the correct value of y that we will get is basically the one where x is negative. Yeah, when the correct value of y that we will get will be by using this as the value of x. That means now I will solve for y using the same equation, this one. Okay, so I'll just sort of make some adjustments here. So y, this is the equation that will help us obtain the value of y. The only difference is that now we're using 4 minus under root 3 into 3 minus 4 minus under root 3. Let's see what this gives us. So 4 minus under root 3, we're not going to change that. That is good as it is. 3 minus 4 is minus 1. Minus minus will eventually make it plus. So minus 1 plus under root 3. And let's simplify this. And by the way, you can see that this will give you a positive value only because 4 minus under root 3 is positive, minus 1 plus under root 3 is positive. So ultimately, you will get a positive value. So when we simplify this, we get minus 4 plus 4 under root 3 plus under root 3 minus 3. So let's simplify this. Minus 4 minus 3 is minus 7. 4 under root 3 plus under root 3 is equals to 5 under root 3. And there you go, fellas. This is the y value. Okay, now we can just write our answer nicely. Point P, where x is 4 minus under root 3, 4 minus under root 3, and y is minus 7 plus 5 under root 3. And there you go, fellas. This is the final answer. Okay, let's read the question again and make sure that we've answered it the way the question wanted. Yep, the question wanted exact coordinates of P, and we have done exactly that. So that's the end of question number 11.